Hi guys, we're going to continue with chapter 9, which today we're going to be doing solving quadratics using square roots. You'll see that this is actually a pretty straightforward lesson, not too much in it, and you should be fairly comfortable with this. So let's go ahead and get started. So core concept here, when we're solving by square roots, we've got three different options that could occur, three different possibilities. First one, when your d value is greater than 0, you're going to have two real solutions, okay? So when you get it down to x squared equals d, if your d value is greater than 0, you'll have two real solutions. If d is equal to 0, you'll have one real solution, and that solution will be x equals 0. And if d is less than 0, you'll have no real solutions. It's important that we include the word real in this because when you get into Algebra 2 and down the road in your math career, we have what's called imaginary numbers. But in this particular case here, if your d is less than 0, we just say there's no real solution and we move on. So let's take a look. We're solving these problems using square roots. So when we solve by square roots, what we want to do is we want to get that x squared by itself. So we want to isolate the x squared. Just like when you would solve an equation, you would get x by itself. You want to isolate x squared and get x squared by itself. So in essence, you're solving for x squared. So we're going to start by adding 27 to both sides. That'll cancel. And now we're left with 3x squared equals 27. Divide by 3, divide by 3. X squared is equal to 9. Now, when you get to this point here, in order to get x by itself here, you have to take the square root of both sides. So we take the square root of both sides, and we're going to get x is equal to, now the square root of 9 could be two things. It could be positive 3 or negative 3. So we can either write our answer as plus or minus 3, or we can say x equals 3 and x equals negative 3. So it doesn't matter how you write it. Either way is correct. Let's look at example 2 here, or B. Add 10 to both sides, and you're going to get x squared is equal to 0. So this is one of our cases where x squared is equal to 0, so we know there's only one solution, and that solution is 0, because the square root of 0 is just 0. And let's look at our last example. We have to get this x squared by itself, so we need to isolate this x squared here. So let's start. Just like you would solve any equation, let's subtract the 11 to both sides. So now we have negative 5x squared is equal to positive 5. Divide by negative 5 on both sides. And we have x squared is equal to a negative 1. This is an issue. Oops. This is an issue because I cannot have a squared. Nothing squared could be equal to a negative number. So when you have x squared equal to a negative number, that's your cue that there is no real, and let me throw the word real in there, real solution. Because like I said, there are imaginary solutions here. So x squared can never be equal to a negative. When that occurs, there is no real solution. Let's keep going. Now, a little bit different here, but same idea. Example 2, we've got x minus 1 squared in parentheses is equal to 25. Well, there's nothing that's around that x minus 1 squared. So what we can do is we can just start by taking the square root of both sides here. When I do that, I'm going to get x minus 1. Now, remember, the square root of 25 can be either 5 or negative 5. So I'm going to have two solutions here because I have x minus 1 equals positive or negative 5. So let's write our two cases here now. X minus 1 equals positive 5. X minus 1 equals negative 5. Here I can add 1 to both sides. We're going to get a solution of x equals 6. Add the 1 over here. And I'm going to get a solution of x equals negative 4. If I wanted to just quickly check these to make sure that they work, I could plug in those answers back into my equation. So if I try for 6 minus 1 squared, is that equal to 25? Well, then I got 5 squared, and 5 squared is definitely equal to 25. What about negative 4? Negative 4 minus 1 squared, is that equal to 25? Well, then I get negative 5 squared, and negative 5 times negative 5 is definitely 25, so that works as well. I want to take a look at an example like number 5. Because on number 5, there's a couple things happening here. You notice how the x squared is not by itself, so we have to start by dividing 4 on both sides here. Now we're going to be left with x minus 3 squared equals 9/4. Now, when we take the square root of both sides, the square root and the square cancel out, so you're just left with x minus 3. Get rid of that. And now you have to remember back to your square root rules. That's why we did this first lesson. The square root of 9/4 is the same as the square root of 9 over the square root of 4, which is just positive or negative 3/2. So now we have x minus 3 equals positive or negative 3/2. And now we could write our two equations as x minus 3 equals positive 3/2, and then x minus 3 equals negative 3/2. Solve for x on both of these, so add the 3 to both sides. On this one, you'll get x equals 4.5 or 9/2. And then over here, you're going to get x equal to positive 3/2 or 1.5. So that's a little bit more of a challenging example there. So I just wanted to show you that one. Remember, step 1, isolate the absolute value. So again, here's one more to just do just for fun. Subtract the 12. X squared is equal to negative 2. The second you see a squared equal to a negative, no real solution. What about on this one? We'll do one more. Here, square root. The square root and the square cancels. So now we've got x plus 7 equals, well, just square root of 0 can just be 0. So you're only going to have one answer here. Subtract the 7 and you get x equal to negative 7. All right? Let's solve this one. They're asking us to round the answer to the nearest hundredth. So we've got 4x squared minus 13 equals 15. So let's start by adding 13 to both sides. Now we've got 4x squared equals 28. Divide by 4, divide by 4. X squared is equal to 7. So we know 7 is not a perfect square, so we're going to take the square root of both sides. We're going to get x equals positive or negative square root of 7. So that would be our answer in radical form, but they're asking us to round this to the nearest hundredth. So then we have to go ahead and we have to put square root of 7 into our calculator. The square root of 7 is 2.65. So x is equal to, well, not equal to, approximately positive or negative 2.65. So again, I have to use the calculator to get from here to here. Okay, all of these are just the same exact idea. So you're going to have to use your calculator to get that final answer. And remember, there's two solutions, positive or negative, whatever that value is. Last example, example 4, I think last one. Oh, might be 2 more. A touch tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and the width of the tank. So we know that volume is equal to length times width times height. So we know that the height is equal to 3 feet. We know that the length is 3 times the width. So let's call the length, let's call the width equal to W. And let's call the length is 3 times its width. So then the length would be 3W. And we know that the volume is equal to 270 here. So the length times the width times the height. So 3 times W times 3W is equal to 270. Now let's solve this. 3 times 3 is 9, so I have 9. W times W is W squared, so 9W squared is equal to 270. Divide by 9 on both sides, and you're going to get W squared, 270 rather, divided by 9 is going to be 30. So W squared is equal to 30. Let's square root both sides. I'm going to get an approximate answer here because the square root of 30 is not a exact value. So I'm going to round that. Square root of 30 is 5.48 approximately. Now, there is a negative value here, but I don't care because we don't have a negative width. So we have the width at approximately 5.48. We know the length is equal to 3 times that value. So 3 times 5.48. And let's throw, what are we talking about here? Feet. So our length, if I do that math out, is approximately, and it's approximately because I'm rounding that square root, 16.44 feet. So again, we use square roots to solve this. That's just an example of a type of problem that you could see in the real world. All right? Good luck. Have a great day, guys.